Dear students, having discussed the sampling distribution of the difference between two sample proportions, given that the samples are sufficiently large, we consider the large sample hypothesis test for two population proportions using independent samples. That is, we developed a testing procedure to compare two population proportions. That is, a testing procedure for comparing two population proportions. The first step is to identify a tested statistic. The first step is to identify a tested statistics. From the sampling distribution of the difference between two sample proportions, the standardized version can be written as Z is equal to E hat 1 minus E hat 2 minus E1 minus E2 by root of E1 into 1 minus E1 by N1 plus E2 into 1 minus E2 by N2. So the test statistics is, we use this standardized version of E hat 1 minus E hat 2 as the test statistics, and this quantity has approximately standard normal distribution. And to test the hypothesis that P1 is equal to P2, this is our H0, P1 is equal to P2, then this Z becomes P hat 1 minus P hat 2 divided by, since P1 is equal to P2, we write it as root of P into 1 minus P by N1 plus P into 1 minus P by N2, using the fact that P1 is equal to P2. And P is the common value for P1 and P2 because P1 is assumed to be equal to P2. And factoring out this P into 1 minus P, this can be written as P hat 1 minus P hat 2 divided by P into 1 minus P into root of 1 by N1 plus 1 by N2. So this serves as the tested statistics. That is P hat 1 minus P hat 2 by P into 1 minus P into root of 1 by N1 plus 1 by N2. We use only Z statistics. T test statistics is not used to test the significance of one proportion or to compare whether two proportions are identical. It is a large sample test applicable only for large samples. As we have seen, NP n into 1 minus P greater than 5. Now this formula cannot be used because P is unknown. P is the population proportion. So P into 1 minus P is unknown. So we must estimate P by using the sample information. So the best estimate of P is obtained by pooling data to get the proportion of of success in both the samples combined. So we use as our estimates P hat as equal to x1 plus x2 by n1 plus n2. The best estimate of P is obtained by pooling data to get the proportion of success in both the samples combined. That is, P hat P is the pooled sample proportion. Then the test statistics become P hat 1 minus P hat 2 by, instead of P into 1 minus P, P hat P into 1 minus P hat P into root of 1 by n1 plus 1 by n2. So this is the test statistics. The test statistics used to compare two population proportions, and all the quantities are known in this case. Now let me explain the steps. The procedure is based on assumptions, simple random sample, which we repeat in all the cases, independent samples. Then x1, n1 minus x1, x2, n2 minus x2, both are 5 or greater than 5 or greater than 5. Given these assumptions, the first step is h0, p1 is equal to p2, h1, p1 is not equal to p2, p1 is less than p2, p1 is greater than p2. The second step is determine alpha at 10%, 1%, 10%, etc. Significance level. The third step is compute the value of the test statistics. Compute the value of the test statistics where P hat P is given. Then the critical values are, as usual, Z minus Z alpha by 2 to Z alpha by 2 for a two-tailed test. For a left-tailed test, minus Z alpha. For a right-tailed test, Z alpha. Then compare the value of the test statistics with the what is known as the critical values, and accept or reject H0, or reject or do not reject H0. Now, let me consider the example we have discussed earlier. In the example, 740 for men, 430 for women, taken by using independent random samples, 276 men, 195 women, with sometimes order beds. At alpha is equal to 0.05, we have to test the hypothesis that P1 is equal to P2 versus H1, P1 is less than P2. Alpha is 5%, so minus Z alpha by 2 is minus 1.64. Now, we can have P hat 1% of 0.364, calculated earlier. P hat 2 has 0.449, calculated earlier. And P hat we say that the proportion of men who sometimes order vegetarian food is smaller than the proportion of women who sometimes order the vegetarian food. That is the procedure for testing two proportions based on independent samples. Now, just as we have constructed confidence intervals for one population proportion and determination of the margin of error, sample size, etc., we can do the same in the case of what we say confidence interval for two proportions as P1 minus P2 is equal to P1 minus P2 plus or minus Z alpha by 2 of P1 into 1 minus P1 by N1 plus P2 into 1 minus P2 by 2. And in our example, if you substitute the values, you will get the results. And the margin of error is Z alpha by 2 into root of P1 into 1 minus P1 by N1 plus P2 into 1 minus P2 by N2. Then that is the margin of error, and the N1 is equal to N2 can be calculated as 25 into Z alpha by 2 by P square. These are only repetitions of what we have discussed, so I am not elaborating on this. So we can construct 90 or 95% confidence interval. We can determine the margin of error, and if you determine alpha and margin of error, you can determine the required sample size using this formula. And that is all about constructing confidence interval and testing the significance of population proportions.